Hello everyone, my name is Aljuri Mdairi. I'm a student in Kuwait University taking the Biometric Modeling and Architect course, and my final project was to study and remodel the Shin district, or also known as the Shin tree, using grasshopper definition. Starting the definition, these are a few interesting moments I found. As example, this shape that grows out from the ground, the different height and the tilting of the roof, and also the symmetry in the plan, as we can see here, and even the height of the buildings, that the front are usually the shortest and it starts growing gradually. And now we will start with the definition. Okay, starting off with the circle on the ground, which I divided, had a line go from the centers, and then dividing again and moving the top to create an arc, which I swept through to give it thickness. And then using kangaroo simulation, I had the point from the arc and the point below to be my anchor points. And then it gave me this shape, which I later mirrored. As we mentioned earlier, there is a mirroring axis. And then moving again, and mirroring again across. But the last mirroring need to be stretched, so I use a scale NE to stretch it out, and then splitting it, which gave me this project. For the other rectangle window, I used the same logic, but started with a rectangle, and the only difference is that I had two arcs and swept for both of them, and using both of the sweep as my anchor points, which gave me this simulation. So starting with the roof, I had the basic rectangle shape, which I made into a surface, and then to split it, I had two different rectangles that I extruded and made a mesh out of them. Using mesh split, I ended up with having my roof, which I take it into kangaroo simulation, having the corner as my anchor point, and gave me this final form of the roof. Okay, as for the second floor of the building, I had my base shape, which came from splitting different of these two curves, and then I mesh shafted it, which is a battery in bufferfish, and had the weather-bird window, the frame, and thicken the frame. They are quite parametric, so I can change the number in both sides. And this is it with the roof. Okay, as for the first floor of the building, I had my original curve, but this time I region differented with this rectangle to create the pathway. And then following the same procedure, mesh lofting and the window. But the only difference this time, I had deconstructed the Europe, evaluate the surface, and only took the z-axis so I can have the roof, which gave me this final outcome. Column, I first took the roof mesh, I took the edge and then reconstructed and extruded it, made a mesh out of it, and then I offsetted the mesh inward to make sure that my column stays inside the roof, not outside. And then I took the vertices and made it as a plane, took it as the plane for my rectangles. I moved it downward and scaled it so I can loft and have my taper shape. And this is the final form of the main building. For the roof, I first took the curve, deconstructed it, and then moved it upward as the point, made a surf, and then a mesh. It's quite parametric, so I can change the tilt of the roof itself. Having the corner of the mesh using the same logic in kangaroo, I ended up having the mesh flowing, and then thickening the mesh and giving it window and frame gave us this final outcome. Column, it also followed the same logic, so I'll just run through it quickly. It has been extruded, offsetted, and then points placed in the rectangle, scaled, and lofted. And this is the final unit that will be placed around the area in the plaza. Original unit is ready. I needed to have my rectangle. I took a few and I extruded them using grasshopper and a random battery. And then I used panel and mesh thicken and window to give it. And then I turned it into a poly surface, deconstructed to have the roof, and took the area so I can have the center point. And then using bounding box, I box morphed it into my original curve, and then taking the area and moving each one into the original area of the groove here so that it moved. And then thickening the mesh and scaling it up so it will be bigger than the base. As for the column, it followed the same logic. So I took the groove, I offset it, I took the point, make rectangles, and then locked it. And this is my outcome. Final outcome after doing all of them. And the reason why I separated is because I needed more control on the height, and also because three units do have get mirrored. So this is the mirrored version, and this is the outcome. That I loved it. And then for the base of the tree-like shape, I had a circle. I marked the circle using a graph mapper, and then I had my own curve that I used the marked circle to array on it, and then sweeping. And then I arrayed it, which I can change the height of it using this graph mapper. And it has been done the same for these two level, but the only difference is these two have different shape for the circle. But then they all merge together, and all of them use this graph mapper for the height, so they go together. And that's it.